Hello everyone, this is Harjit Sani. I welcome you all in the next lecture of 12th class NCERT Mathematics. In this video lecture, we will discuss the main topic minors and cofactors. On the basis of these topics, we will discuss complete exercise 4.3. So without further ado, let's get started. The topic is, this is our third topic, that is minors and cofactors. Okay, so what is minor actually? The determinant obtained by deleting the ith row and jth column passing through the element aij is called minor of the element aij denoted by mij. How we can denote? By the mij. Okay. Now, to discuss this one, okay, we can go by the example. So here they are saying we have a determinant 1, 6, 2, 2, 4, 3, 3 minus 1, 4. The minor a11, okay, correspond the minor of a11 we need to find. Here we have actually corresponding to a11 position, corresponding to a12 position, corresponding to a13 position, corresponding to 21 position, 22 position, 23 position, we can find minors. Okay, and how we can find? Suppose here we need to find a11 corresponding to a11. The element a11 is this one. This is first row and first column. So this is our a11 element. So we need to remove this one row and this one column. Okay. So what we are left 4, 3, minus 1 and 4. Okay. So we need to find the determinant of this one 4, 3, minus 1 and 4, and after solving we get a number. Okay. So basically the minors are also a number which are obtained corresponding to an element of the matrix by removing that particular ith row and jth column. Okay, suppose in the same determinant, okay, and someone asks you to find the minor corresponding to the third row and second column. So we need to remove the third row and second column, because third row and second column, third row is this one, this is our R3 and this is our C2. Okay, so we need to remove the second row and third column, second column and third row. What we are left with, this is our representation M32, and we are left with 1, 2, 2 and 3, and just simply solve, we get the answer, that is minus 3. Okay, I hope you understand what is minor. Okay, like that we can find the minor corresponding to each entry. Okay, so suppose you have a matrix of size a11, size 3 cross 3, a11, a12, a13, a21, a22, a23, like that we have. So corresponding this entry we can find is this one, this one, this one, this one. So how many minors we have corresponding to a matrix of size 3 cross 3? Total 9 minors we have, because we can find corresponding to each entry. Okay, I hope you understand this thing. Now observe here, some key points are there. These things you need to keep in mind. In determinant of order 3 cross 3 we get 9 minors. This thing I already told you, as we have 9 elements. Suppose we have a matrix of size 2 cross 2. How much? 2 cross 2 matrix size. Okay, that is a11 position, a12 position, a21 position, a2 position. So clearly we have 4 minors for this particular matrix of size 2 cross 2. So if 3 cross 3, 9 minors. If 4 cross 4, 16 minors we have. Like that we can have. Now, the minors of an element aij of a determinant of order n greater than n equal to 2 is a determinant of order n minus 1. What they are saying, that here we can observe in above. See, it is 3 cross 3 determinant. It is size of this determinant is 3. Okay, if the size of the determinant is 3, then you can observe that the minor for that one, for any element, if we are finding the minor for any element, then it will be of size 2 cross 2. Why so? Because if corresponding to this aij we are finding the minor mij, okay, namely, then we need to remove the ith row and jth column. So observe that one row and one column are reduced already. So we are left with reduce. If here 3 cross 3 we have, then we have 2 cross 2, because one row and one column we already removed, and hence we are left with 2 row and 2 column. That's why. I hope you understand this thing. Okay, if you have any doubt still, then you can do comments. I will explain again. Okay, so that's why the size is n minus 1 size for or any order of n. And why they are saying n greater than equal to 2? Because if you are taking 1 cross 1, okay, if you are taking 1 cross 1, then what we have, only one element is there. And if only one element is there, then by removing that one row and one column, what we are left with nothing. Okay, so the minor for that single element is same as that is, suppose you have you have here 1 1. Okay, so m11 is a11. Okay, m11 is a11, only this one we have. Understand? But for, suppose we have 2 cross 2 matrix as this one, like that, a11, a12, a21, a22, 2 cross 2, then, and we are finding corresponding to a11 minor. Okay, so minor denoted by m11, and how we can find, remove the first row and first column, so we are left with a22 element. Okay, this is our minor, and the size of this minor is 1 cross 1. Understand or not? Okay, now move on to the next thing, that is cofactor topic. Okay, so cofactor is also cofactor is also basically a number. Okay, and it is determined by the help of the minors. Okay, here observe, in a minus we don't have plus minus sign, that is in front. Okay, just we have a determinant of 2 cross 2, and when finding the value, either it is maybe positive, maybe negative, maybe 0. Okay, anything. But here we have some importance of the position also. Here we have the formula is Cij equals to minus 1 raised to the power I plus j mi j. Here you can observe, this is the formula we have. Okay, the notation is Cij, and in NCERT is written Aij. Okay, it may be possible in exam they are giving Aij, Cij. It may be possible they are defined by itself also Bij. Okay, so no need to worry that what Bij. Bij is nothing but a minus 1 raised to the power I plus j into mij. Every time this thing is same. Okay, and these things are remain, may be changed, may not be changed, but these things remain unchanged. Okay, so now let us discuss this property by this definition by the example. So here we have a determinant 206, 3 minus 2 minus 4, 1 1 3. Then they are saying cofactor corresponding to the position a11 we need to find. If we are finding the corresponding to a11, this will be denoted by the c11, or we can say it is denoted by the a11. Okay, and what it will be, minus 1 is the formula we need to apply, 1 plus 1, 1 plus 1, and here we have m11. So it is minus 1 power 2, that is even, and it will be only m11. So basically c11 is nothing but exactly m11, and we know how to find m11. m11 position is, we need to remove the first row and the first row and first column. So what we are left with, minus 2, minus 4, 1 and 3, and just we can solve it simply and we get minus 2. So this is our C11. Understand? Same as that, if someone say the find corresponding to the element A22, how we can find corresponding to A22? First of all, the cofactor name is C22. Okay, and formula is minus 1 raised to the power 2 plus 2 m22. Okay, and it will be again as m22. m22, how we can find? Observe here, we need to remove the second row and second column. So what we are left with? We are left with 2 6 1 3, and we can simply solve. 3 to 6 minus 6, we get 0. So C22 will be 0. Now we observe that in both these one A11 and A22, this minus 1 minus to the power something is becomes always positive. So let us take another example. in which we have it becomes negative. Okay, so here we have the position is, you can take the A23 position, you can take for A23 position the cofactor is C23, and how we can find minus 1 is to the power 2 plus 3 M23. Okay, and here will be minus M23. Now we have M23s, we can find by deleting the second row and the third column, second row and the third column, second row and third column, we are left with minus sign has to be there outside. Okay, that's why I'm saying that the importance of the position is there. To position in the sense of plus minus sign. Okay, nothing but, and here we can simply solve minus 2 0 minus 2 only. Okay, I think you got idea that how we can find the cofactors, okay, corresponding to each entry. So again the cofactors are also 9 or not. Okay, move on to the next one. Now here, now in your mind, one question will come that why, sir, we are discussing this cofactor and determinant, these cofactors and matrices, minors for a given matrices, for a given square matrices. Actually, these minors and cofactors helps us to find or expand the determinant or find the value of the determinant. Okay, because actually there is everything is connected here. Okay, I'll tell you with a bit of time. Okay, after some time I will tell you that what is the actual use of the finding matrix for a square matrix, cofactors and minors. Okay, but in this complete exercise we are just finding how we can find minors, how we can find cofactors, how we can expand the determinant. And now here we have expansion of determinant in terms of cofactors. Suppose we have a matrix A. Okay, A11, A12, A13. Why I'm always taking 3 cross 3? Because in your course now, most of the times, in most of the book, it is used 3 cross 3 matrix, and in also the exam, from the exam point of view, the 3 cross 3 matrix is much more important as compared to the higher order. You can also take 2 cross 2 matrix also. Okay, A21, A22, A23. Here A31, A32, A33, and this is 2-1 position now. Now, how we can find the determinant? If someone say find the determinant, actually determinant is nothing but a scalar value. Okay, with the maybe positive, maybe negative, maybe 0, associated with the square matrix. Okay, associated with the square matrix, and the determinant is always unique for a given matrix. And how we can find that scalar value? See, if we are expanding the determinant along, this is first row, this is second row, and this is our third row. This is our first column, this is our second column, this is our third column. Okay, now first thing is you can expand the determinant. How we can denote the determinant? Like that we can denote it. Like that we can denote also. Okay, yeah. Here this determinant we can expand for a given matrix along the first row, second row or third row, or the first column or second column or third column, and the value of the determinant is remain unchanged. And how we can find along the first row? You have the element A11 corresponding cofactor C11 multiply and then add A12 corresponding cofactor C12, A13 corresponding cofactor C13. That is the value of the determinant A along the R1. Same if we are expanding along the third row, A31, C31, A32, C32, and A33, C33. Okay, it may possible someone ask that, sir, finding along the first column, then it will be A11, C11, A21, C21, and A31, C31. Okay, and this is also represent determinant, this is also represent determinant, and this also represent the determinant. Okay, now same as that you can find along the C2 and C3 also. Now the main thing we have here, this thing, this is also the main thing. Okay, the first part is also main thing. You have actually two part, A and B, for the given this topic expansion of determinant in terms of cofactors. In a determinant, the sum of the product of an element of any row or column with the cofactor of the any other row or column is 0. That means they are saying that suppose you are taking the element of the first row a11, a12 and a13, and cofactor you took of for r2 or from r3. Suppose I am taking from r2, that is c21, c22, c23, and what we are doing, a11, what we are doing actually here, a11, c21, a12, c22, a13, c23, it will be 0 all the times. Actually the definition, it will be a statement. Okay, if you have element, and you multiply by the corresponding cofactors, the same row, then you are getting determinant, maybe 0, maybe non-zero. But if you are taking the elements of the first row and cofactor of the second or third row and multiplying like that, then guaranteed will be 0 all the times. Okay, or same thing, if you are taking the element of the first column and the cofactor of the second column or third column, then it will also give 0. I hope you understand this property. Now move on to the exercise. Now what they are saying here, write the minus and cofactors of the element of the elements of the following determinant. It means this is the notation of determinant, you already know, like that. Okay, and how what the matrix corresponding with this determinant is 2 minus 4 0 3. Okay, and they are saying find the minus and cofactor for this one. Okay, how we can find, just I am writing this matrix usually. Okay, it is not necessary to write every time corresponding to every determinant matrix. Okay, here they are saying finding the minus corresponding to each element, and that means a11 is, that is 2. So remove this one, what we are left with notation. First of all, notation is for minor is m11, and we are left with 3, so 3 only. Okay, now we have, because it is a minor of 3 cross 3, so we are left with only 3. Now we can find for a12 position is minus 1 4, a12 value is minus 1 4. Okay, and how we can find, denoted by the m12, and it will be 0, so we are getting 0. Okay, same as that a13, not a13 is not there, a21, second row first column, we are left with element is 0. Okay, and the minor is minus 4, determinant, it will be minus 4. Okay, it is not modulus sign, this is not modulus sign. Okay, please don't confuse modulus sign, it is not a modulus sign, keep in mind this thing. It is just a notation to represent for a given matrix 2 cross 2, 3 cross 3, 1 cross 1, 4 cross 4, 5 cross 5, any square matrix, the determinant value. Okay, whenever you see this thing, you just need to expand it, just need to observe that it is just a real value written. Okay, but the format of writing the real value is different. Okay, and that is a representation, like a rectangular or square representation. Okay, similarly we can find for a22 also. Second part you need to complete. A22 equal to the element is 3 only. Okay, and the minus will be have what the minor we have 2. Okay, now corresponding this one, what is C11? Because cofactor they are also saying, find cofactors also. C11 is minus 1 s to the power 2 m11, that is only 3 we have. Okay, C12 minus 1 s to the power 1 plus 2, m12 you have minus m12, and we have 0. Similarly, we have C21 is minus 1 s to the power 3 m21 minus m21, and what is about m21? Oh my god, this is m21. Okay, we have minus 4. Now C22 we have minus 1 is to the power 4, okay, and here we have M22, so M22 is 2 only, that one, okay, yeah, I hope you understand this thing. Similarly, in this way you need to find the minors and cofactors for this second, okay. Now move on to the next one. In this question also we need to find the minors, okay. I will find the minors and cofactor for the first row. Similarly, you need to find corresponding to the second row and third row, um, okay. Now, and same you need to do, okay. So I will do this second because this one is very easy. So here we are finding for this second part with the same manner you can find for the first also. So here A11 is 1. First of all, you need to write the element corresponding to which element you are trying to finding. Then M11, the minor, denoted by the M11. Okay, M11, the minor corresponding to the element A11. Okay, so what will be? Remove this one, this one. We are left with 5. Wait, 5 minus 1, 1, 2. And how we can solve? 10 plus 1 equal to the 11. Okay, now A12. Wait, let me complete this one thing also. By combining both of them, C11 is minus 1 is to the power 2, M11 we have M11 and we have 11, that is C11 also. Okay, now corresponding to the A12 we can find A12 is 0. What about M11? M12, position is M12. How we can find? Remove the first row and the second column. We are left with 3 minus 1, 0, 2, and we have 6 only. So C12 is minus 1 is to the power 3, M12, and minus M12. What about minus M12? M12 is 6 minus 6 we get. Okay. So same thing we need to do for the fourth one. Okay. How we can find? A13, that is 4 element. Okay, element is 4, I think 4 now. Yeah, 4 we have. And wait, I'll write minor also. The minor is 3501. The minor is M13 is 3501. It will be 3 because 3 into 0, 5 into 0, 0. Okay, I already told how we can solve the minor. This one, 1, 6, 7, 8. Okay, how we can solve? 8 into 1 minus 6 into 7, just into 2 and find easily. Okay, now, so here we have C13 minus 1 is to the power 4, M13, it is same as that M13, that is 3. Okay, so like that you can find. Also you need to find this I find here along the first row only. Okay, same thing you need to do for the second row and third row also, and hence for the first part also. Okay, I hope you understand this question. If you have any doubt, then you can do comments now. Using cofactors of the element of the second row, they are saying second row, this is our second row, this is our R2. Okay, this is our R2. Using the cofactors of the element of the second row, we need to evaluate this determinant. Recall that I told you that how we can expand any determinant, okay, along the first row, second row, third row, or first column, second column, third column. But here they are specified along R2 we need to expand our determinant. So first of all, writing the element A21, 2 element is 2, 8. Okay, A21, and A22 is 0, A23 is 1. Corresponding to A21, C21, not C21, but first of all we need to find the first of all we need to write the value of the determinant. Determinant value is A21, corresponding cofactor, A22, corresponding cofactor, and A23, corresponding cofactor. Okay. So here A21 we have 2, A22 0, A23 1. So A22, A21 I will put the value, C21, A22 is 0, 0 into something is 0, so it will be 0. A23 is 1, so C23 only. So what we have at the end, 2 times C21 plus C23. Now we need to find the value of C21. Okay, what is C21 here? C21 is minus 1 s to the power 2 plus 1 m21 position. Okay, so it will be minus 21. Okay, now what is m21? M21 is actually, remove the second row and first column, we are left with 3, 8, 2 and 3, 3 and 9 minus 16 we are getting here, minus 7. So the C21 is, we have 7 we get it. Okay, now next thing what we need about C23. What is C23? C23 formula equal minus 1 s to the power I plus z is 5, and again we have here m23, and here we have negative of m23. But what is m23 actually? M23 is, remove the second row and third column. Second row and third column we are left with 5, 3, 1, 2, 10 minus 3, that is 7. Both are 7, 7. Okay. So now we need to put what is C23? C23 is minus 7. Okay. So both the values C23 and C21 value we can put in the equation first. So the determinant is 2 times plus 7 and minus 7. Okay. So what we are getting here, 14 minus 7 is 7. This is our determinant. If they are saying it along the first row, then also we can find, or the third row along we can find, and same determinant will come every time. Okay. Now we are moving to the next question using the cofactors of the element of the third column. Third column means this one column. Okay. Along the C3, we need to expand this determinant. Okay. What is A31 position? Sorry, A13 position. That is first row, third column, YZ element. Okay, and A23 position, ZX element. A33 position, XY element. Okay, now observe that C1, what is C13? C13 is actually minus 1 s to the power 4 M13 minus 1 is to the power 4. Okay, here what we have actually, here we have M13. Okay, and what we have here actually M13. Okay, now we have C23. C23 is minus 1 is to the power 5 M23, and we are left with minus M23. Next is C33, minus 1 is to the power 6, and here we have M33, and this is M33. Okay, I hope you understand. Now the main task is to find M13, M23 and M33. What is our M13? M13. See, M13 means first row, third column remove. We are left with 1 Y, 1 Z, and we are getting Z minus Y. Okay. Now, what is M23? M23 we can find by removing the second row and third column. We are left with 1 X, 1 Z, and we are left with Z minus X. Okay. Sorry. Now at last we have M33. This is 1. There's nothing. First, third row and third column we need to remove. Third row and third column. So 1x, 1y we are left, and we have y minus x. Okay. Now we need to put this value in above. Okay. What we have C13. C13 is actually what we have C13. C13 is same as that z minus y. What is C23? C23 is minus times z minus x. That is x minus z. Okay. And see what is about C33? C33 is y minus x as it is now. Now what they are saying that expand the determinant along the third column. Now the value of the determinant is third column na? A13, C13, A23, C23, A33 and C33. Okay, and the values are, need to write here. First is YZ, ZX and XY, YZ. A13 value is YZ. Okay, multiply with Z minus Y plus. Okay, A23 is XZ, multiply with X minus Z. And at last A33 is XY, multiply with Y minus X. Now multiply inside. Here we are getting YZ square, here Y square Z, here X square Z, here XZ square, here XY square, okay, and here minus X square Y. Is something is cutting or not? X square Y is somewhere. No, nothing is there. Okay. Just we can simply write here. Plus term we are taking like X Y square. Okay. Then Y Z square plus Z X square and negative X square Y, Y square Z and Z square X. Okay, this is our determinant value, we can simply find. Understand or not? I hope you understand this thing. Along the third row we are third column we are expanding YZ, ZX and XY. Yeah. Now move on to the last one. Here we are saying in the fifth question that A11, A12, A13, A21, A22, A23 and A31, A32, A33. Aij is a cofactor of Aj. Here see, they are changing the Cij as, because we are in all the four questions I am using Cij. So here I will use Aij because they are give itself that cofactor corresponding to element Aij they are representing. Then the value of the determinant is given by, okay, I will check. A11 multiply with A31. No, it is wrong. Why so? Because if we are evaluating the determinant of any matrix, okay. So if we have, suppose we are expanding along the first row, because 1 position, first row we are expanding. So we need to multiply the corresponding cofactor. Okay, but they are multiplying with 3, 1, so it is not true. A11 multiply with A11, yeah, this one is true. A12 multiply with 1, this is not true. Because A12 multiply be with C12, okay, and A13 multiply with this one also not true, hence it is not also, so this is not also true. A21 multiply with A11, this is also not true, hence the option is true. And we observe also that the determinant value they are giving A11 cofactor, A21 cofactor, A31 its cofactor. Okay, here element multiply with its cofactor, corresponding cofactor, multiply with its corresponding cofactor, multiply with the corresponding cofactor. Okay, hence we are getting determinant here. Okay, so I hope you understand all the 5 questions and the concept of this 4.3 exercise. Okay, if you have any doubt in any question or any mistake I did, then you can do comments. I will rectify it and I will do it and explain it. Okay, so thank you for watching. Please share and subscribe.